All right, and in this study of statics, it's very important to know the center of gravity, because whatever you have, could it be a crane, it could be a human being, it could be a ladder, etc. You need to know the point at which the weight of that object acts, right? If you have a uniform object, say something like this, which is a uniform density and it's a uniform shape, that center of gravity is going to be in the geometric center. But oftentimes we don't have that scenario. Oftentimes we have something that, like my center of gravity is not in my center, right? I have more mass up top than I do bottom. So my center of gravity, and yours too, you all are human beings, it's going to be closer to the top than the geometric middle of your person. So we were going to do an integral. The center of gravity, by the way, the center of gravity is defined as those little mr the summation over the total mass. So the summation of all those little masses times the distance from the radius over your total mass. So with that in mind, we were calculating the center of mass of a right triangle. Okay, here's our right triangle. We'll call that A, we'll call this B, this is the x-axis, this is the y-axis, and we are going to we're going to have a center of mass. If you have a volumetric shape, you have a center of mass in all directions, right? But this is going to be just a flat shape. So you're going to have a center of mass along the y-axis and also one along the x-axis. So we're going to calculate that one along the y-axis now by adding up all these little bits of masses along from 0 to B. So we're going to have the m, which this is that m, and then y, center of mass, equals from 0 to B of y dm. And once again, with our integrals, we don't know the dm's. And this is not a volume, so it's not going to be a rho dv. Instead, we're going to have dm is going to be equal to sigma dA. Sigma dA, right? Sigma, this is just an area. It has no thickness, okay? So we're going to, so sigma is defined as mass over area. Okay. Now we're going to take these little chunks of area, and this is going to be right there, a dy. And this, so that's this thickness, right? And this is x, that's simply x. Okay? So our dm is going to be x, sigma x dy. Does that make sense? Okay, very good. So, we have m, y center of mass, equals the integral from 0 to b of y, and then our dm is going to be times sigma x dy. Okay. I will pull out the sigma. The big M times y center of mass equals sigma 0 to b of y x dy. Now I don't want a y and an x in my integral, so I'm going to rewrite x in terms of y. So from the equation of a line, okay, x is going to equal negative a over b times y plus a. That's just mx plus b, where m is the slope. Oh boy, I think I'm killing off my page here. Let's see, I'll get one more Okay. So now my m times y center of mass equals the integral from 0 to b of sigma, pulling that out, negative a over b y squared plus a y dy. Did I make a mistake? Good. All right. All right, now we integrate. So m times y center of mass equals sigma times, let's see, what do we have here? Negative a over b, b cubed over 3 plus a times b squared over 2. And that's it, right?
Yeah.
Minus 0.
Yeah.
This is 0 to b, okay? That's it. All right. So my m y center of mass equals sigma times negative a over 3. I can take the a's out. See that, you guys? Let's just go ahead and do that. Negative b squared over 3 plus b squared over 2.
Wait, how did you take the A's out?
Because I have a 1 there and 1 there.
Oh, I thought the last time you got rid of them is because the sigma was like m over a, and the a had like.
You're right. Oh my gosh. He's right. I can't do that, right? Do I need to do this again?
No, you just replace the sigma with the.
Okay, yeah, all right. Thank you so much, Henry. All right, so we have that. And now we have m y center of mass equals sigma is, once again, mass over area. And we have m over 1/2 b times a times negative b squared over 3 plus b squared over 2. Oh, we added a's, right? A, and the a's go, and one of the b's go. So now, what do I have there? What's my equation? 1/2. I have
It's 2m.
m over m, right? Okay, what else? What's there?
B over 3. Oh, negative b over 3.
Negative b over 3 plus b over 2? No, that's, okay.
It should be 2m on those.
2m here?
Yeah, because it's m divided by 1/2, which is 2.
Okay, and then this was a y center of mass times m, right?
Yeah.
Equals that. So my m's will go. And so this is going to be 2 times 1/6 b, which is equal to b over 3. So 1/3 b. So your center of mass along this axis is 1/3 of the way up. Okay. So yeah, it's going to be very important to learn where your